Hello. So now we'll be discussing the fluid. So this fluid we divide into two segments. One is fluid statics and second is fluid dynamics. The only difference between these two is in first case the fluid is at rest with respect to the vessel, and in the second case, fluid dynamics case, fluid will be moving with respect to the vessel. So first thing we'll study the fluid statics, and that will start with defining the fluid pressure. As you already know, like in case of particle dynamics, we used to have the particle, and those particles used to interact with other particles, and these interactive forces we used to define. They were quite easy to define because there were some fixed number of particles. But when we talk about the fluid, there are infinite particles which constitutes this fluid, and these infinite particles will keep interacting with the other particle, and interacting forces of these infinite particle, we cannot study those forces. It's not possible for us to study those forces. But these interactive forces, they create some effect onto the things which are inside the fluid. So we need some sort of method to study these interactive forces which are acting between the particles of the fluid. And that mean is fluid pressure. So what we do, the fluid pressure, we define it by P. We take a hypothetical cross-section area inside the fluid. Any hypothetical cross-section area, it can be real as well as hypothetical. And that hypothetical cross-section area, these particles which constitute this fluid, they'll keep interacting at this cross-section area. And the direction of these interacting forces will be random. And as we already know in case of fluid dynamics, when the force is random, we define that random force with the help of two mutually perpendicular components. So what we do, these interactive forces which are acting at this cross-section area, we define these interactive forces by taking two components. One, dF perpendicular, and the second force, obviously, we will take dF parallel. So the net resultant of this dF perpendicular and this dF parallel will be the interactive force at this cross-section area, this hypothetical cross-section area. And obviously, around this area, on each side of this area, there are particles and they are interacting at these areas. So there will be two forces, one on the left side and one on the right side. Similarly, there will be one more force here. So if I want to study these interacting forces, we have to study both of these forces, meaning this perpendicular component of the force as well as the parallel component of the force we have to study. So we will not be studying them simultaneously, we will be studying them one by one. So the first force we are interested in is this perpendicular component. So this perpendicular component we will study first. Okay, so what we do, in case of pressure, we define pressure obviously at this cross-section area as the perpendicular component of force divided by this cross-section area. That's how we define the pressure. So we have means to calculate this pressure. We have means. So by means of calculating the pressure, we'll be calculating the perpendicular component of force. At later stage, we'll define the means to calculate this parallel component also. We call it as viscous force. This viscous force is the parallel component of the force. We'll do that later on. The first thing is d perpendicular. So any cross-section area, any hypothetical cross-section area, at that cross-section area, we define the perpendicular component of the force, and this perpendicular component of force divided by the cross-section area is defined as pressure. This pressure is a tensor quantity, but for all practical purposes, we can assume this pressure as a scalar quantity, meaning we cannot assume it as a vector quantity. It's not a vector. Okay. So let's talk about the units of this pressure. When we talk about the units of the pressure, the unit of the pressure is defined as Pascal, or in short, we call it PA. We call it PA, Pascal. Along with that, as you can see, this is force upon area. This Pascal is nothing but Newton per meter square. So that's how 1 Pascal is equivalent to 1 Newton per meter square. That will be the relationship between the units. So if there is a unit cross-section area, and onto that unit cross-section area, if unit force is applied perpendicular to that area, we'll get 1 Pascal pressure at that point. So we have methods to calculate this pressure. That's how we define this pressure.